Hello students, I hope you all are doing good. Today we are going to solve the BPT 11. I am Aviraj, Physics SME at MEMONEET. I am here to solve the BPT 11 Physics section. So we will start our questions, explanations and thereafter we look after the answer and solution. Okay, now moving to the first question. As you can see, the first question tells two coils C1 and C2 are placed near to each other. When current changes by 2 ampere in coil 1, the magnetic flux changes by this in coil 2. It's the concept of mutual induction. Now, moving to the explanation, as you can see, let me change the color of it. Yeah. Let phi 2 be the flux in C2 when the current in coil is I1. Okay, you know principle of mutual induction, phi 2 is given by M I1. And the flux in the second is dependent on the current on the first. Here M represents the coefficient of mutual induction. Now, change in flux is given by M change in current. Now, change in current is given by 2. Change in flux is given as a 0.8 Weber. So M, which is the coefficient of mutual induction, it will come out to be 0.4 Henry. So your correct option will be option number A. Now moving to the next question. Okay. It says that magnetic flux in a circuit containing a coil resistance is given. Magnetic flux change is given. Charge. You know delta Q charge is given by change in flux upon R. Simply put into this formula and get the value of delta Q. Same is done here. Initial flux is given, final flux is given, and resistance is given. So you can calculate it out from the current. That the current is a EMF upon R. You can do in this way also. Like charge is, it is done in a different way. They have used the concept of EMF, Faraday law, then calculate the EMF, then resistance. You can do in this way also. It is given by the change in flux upon R. Change in flux is simply 10 minus 2 means 8 by R is 2 means like 4 coulomb charge should be. Yeah, you can see the answer is the same. You can do in this way in one line. So D is the correct option. They have done in different way. Okay. Now moving ahead. It is talking about LCR circuit. Change in the capacitance is given. Same resonance frequency remains unchanged. Means omega, which is the resonance frequency 1 by root LC, it remains the same. It is asking about the inductance. Okay. Now you know if the omega is same, means like omega initial equals to omega final. You can change the C and you can calculate how L is changing. You can see in the solution, omega is given by this. So omega 1 by omega 2 is omega 1 is equals to omega 2 as the resonance frequency is the same. So putting the values, squaring the things, you get the L2 is nearly equals to L by 4. This is like 1 by 4 times. So correct option is option number B. Now moving to the next question. LCR circuit, inductive reactance is given, capacitive resistance is given, and resistor value resistance is given. Connected AC source, the voltage source is given, power dissipated is given, the power displaced in the resistor. But it is asking about the power consumed in the resistors. In LCR circuit, there are three components: inductor, capacitor, and resistor. It is asking about the power used or power taken in the resistor circuit. Now looking into the solution, first you can calculate the impedance, which can be given by Z equals to under root of R square plus X 3 minus XL ka whole square. Putting all the values, you get the impedance equals to this. Now, you know current is equals to potential upon impedance. So you get the current. Now power can be calculated, as you know, in the resistor, power is calculated by I square R or V square by R. So we calculated the current using the voltage given and the impedance given, and we calculated the power dissipated. It will come out to be 2 to 5 watt. That means option number third is your correct answer. Now moving ahead. Okay, a step down transformation, if in mind, connected to a main supply of 220 volt, made to operate at 11 volt, 44 watt. Okay, lamp, ignoring power losses. What is the current in the primary circuit? It is the current asking about the current in the primary circuit. You know, like is the like transformation, we have generally two formulas. One is NP by NS equals to VAP by VS reciprocal to IS by IP. Simply using that formula, as you can see in the solution, VP is given, VS is given, power is given. You know, VIPI equals to VSIS. Equating this equation, you can get the value of IP, and IP will tell you the value of current, which is asked in the like question. So by you can just use this simple formula and get the answer. So your correct option will be option number C is your correct answer. Now moving ahead, a metallic rod completes its circuit as shown in figure. The circuit is normal, okay, magnetic field. Like magnetic field is normal to the plane. Resistance is given. Force required to move is velocity. It's a simple question. Like resistance is given, like velocity is given, magnetic field is given. You just need to calculate the current. Once you calculate the current, you will get the value of force. Now looking into the solution, length is given, magnetic field is given, resistance is given, velocity is given. You just need to calculate EMF first. EMF is given by BVL. B is the magnetic field, B is the velocity, L is the length of the conductor. Now from here you can calculate the current. As I said, you need a current to like IBL, because the force is IBL. So you need IBL. To get current, you need EMF. From EMF you get the current. Then using the formula of force, which is equals to IBL, putting the values, you get force is equals to 3.75 10 to the power minus 3 Newton. So the correct option will be option number A is your correct answer. Now moving ahead, a coil having area is given, magnetic field change in magnetic field is given, EMF induced it is asked. Is again a Faraday law question, you know, as you can see in the solution. By using Faraday law, EMF is equals to negative of change of flux upon time. Putting the values, you get the EMF, and magnitude of EMF is this. So 3 A naught B naught by T. So the correct option will be option number A is your correct answer. Now moving ahead to the next question. All are basically, you can see, the formula based questions, or somehow little bit analysis is required, and initially the questions are little bit easy. Let's see, as we will move proceed, there will be little bit good questions there. The magnetic flux is given by this. This magnetic field is changing with the time. Now it is asking induced EMF at T equals this. You know EMF again with the same formula, like minus d phi by dt. Now differentiate it and put T equals to 1 second. As you can see in the solution, here flux is given, EMF magnitude of EMF is given by this formula. Putting the value, you get EMF is equals to this. Now it is asking what will be it is induced at T equals to 1 second. Okay, so it is asking at T equals to 1 second. So at T equals to 1 second, from here you get that sign, since sine phi pi, as you can know, it's a integral multiple of pi, so its value will be 0. So it will come out to be 52. So the EMF will come out to be 52 volt. That is your option number first is your correct answer. Now moving ahead, the power factor in purely resistive. It's simply, you know, the power factor in purely resistive can be calculated by what? You know, power factor is given by cos pi factor, and in purely resistive pi is equals to 0. So power factor is 1. So B is the correct answer. It's again a theoretical question completely. Now moving ahead, the current in AC circuit is given by, current is given, it changes with the time. The time interval, it will be 0 to peak. It is asking about the time interval, it is asking. Okay. You can see here, it's a sine graph, but its omega is 50 times, which frequency increases. So you just need to calculate the time after which it gets 0. Okay, as you can see, omega is 50 here, 50 pi is your omega, because general equation is what? I naught sine omega t. So in the place of omega, there is a 50 pi. So omega is given by this, you know, time period is equals to 2 pi by omega. From here we get the time period. Time period is 1 by 25 seconds. So time period is 1 by 25 seconds, means like at 1 by 25 seconds it gets 0 again. So you can calculate from here as t equals to t by 4. So your t will come out to be 1 by 25. So small t will be 1 by 100. That can be, you have to write in the terms of option, that is in the millisecond. So 1 by 100, if you convert into the millisecond, it will come out to be 10 milliseconds. So the correct answer will be your option number A is your correct answer. Now moving ahead, a rectangular coil of single turn having area this rotates in a uniform magnetic field with an angular speed omega in the field. If the initial plane of the coil is perpendicular to the field, the average induced EMF when it is rotated by 90 degrees. It's again a question of change in flux, and then you need to use the EMF Faraday law concept. Then you get the value of the EMF. You need to write initial flux, thereafter final flux, then you get change in flux, and omega, like it is given moving with the omega simply. So you can convert in, see the means in time, means like delta t, you know time equals to 2 pi by omega. So put the value of time in terms of omega and you get the value of EMF. As you can see in the solution, initial flux is given, final flux is given. By using Faraday law, you get change in flux upon change in time. Change in time can be given by the using the omega. Putting the value, you get EMF is equals to 2 ba omega by phi. So the correct option will be option number D. It's again based on the Faraday's law concept. Now moving to the next question. A metal rod of length 2 meters is rotating about its end with an angular velocity 100 radian per second, plane perpendicular to the uniform magnetic field B. If the potential difference between the end of the rod is 60 volt, the magnitude of magnetic field will be. It is asking about the magnitude of the magnetic field. Now moving to the solution, as you can see, what are the given quantities? The length of the rod is given, the angular velocity is given, the potential difference at the end is given also 60 volt. Now what it is asking? It is asking about the magnitude of the magnetic field. You know, if a coil of some radius is moving, the magnetic EMF induced in the coil is given by BL square omega by 2. So we is EMF. So we know EMF, we know omega, we know L, we know 2. We just need to calculate B. So it's a simple equation. Putting all the values here, you get B equals to 0.32 Tesla. So B is simply 0.32 Tesla. Let me off the Wi-Fi. Okay, yeah. 0.32 Tesla. Okay. So your correct option will be option number D is your correct option. Now moving ahead, the next question. AC circuit shown in the figure, source EMF voltage is given, RMS voltage, VRMS is given, and variable frequency at resonance circuit. You know this is R, this is your XC, this is your XL. So from here you just need to calculate the what it is asking and variable frequency at resonance. Okay, at resonance it is asking. You know resonance condition. Resonance is given by 1 by root under LC. So this is our resonance condition. And also resonance condition at Z equals to R. This is also our resonance condition, and all the complete circuit becomes like a resistive circuit. As you can see in the solution, like RMS voltage is given, Z at resonance, these are the condition of resonance. Putting the value, we get the current value. So once you get the value of current and getting out the frequency value, so frequency will be 250 hertz. So at resonance, it is can be देखो omega is equals to 1 by root LC. Okay, omega is equals to 2 pi f equals to 1 by root LC. So from here f बराबर what 1 by 2 pi under root LC. Putting the value of LC, you get the value of frequency. As you know, frequency is 250 hertz. So RMS current 10 ampere. Yeah, it is also correct. Frequency this. So A B means option D is your correct answer because A and B both are your correct options. So your answer, final answer will be option number D. Now moving ahead, again the question of transformer. Transformer is used to light up 100 watt, 110 volt from 220 supply. If the supply current is this, efficiency of the transformer. Okay, it is asking about the efficiency. You know, generally efficiency is given by what? Efficiency is the output voltage by input, or in the term, if it is power is given, or so output power by input power into 100, output power by input power into 100. Now moving to the solution, input power is given like 220 volt into multiply by current because power is given by VI. So from here we get input power and we want output power 100 watt. So the efficiency is 90.90%, 90%. This nearly approx to 90%. So D is your correct option because efficiency is given by output of something by input of something. Here it the values of powers are given here, so you can calculate by using the power or the efficiency of transformer is given by output power by input power into 100. If it is asking you in terms of percentage. Now moving ahead, A DC emitter shows a reading of 1 ampere for a circuit containing a coil connected to 100 volt DC source. The same coil carries this current when connected to this volt and it's not this frequency. The inductance it is asking. Now moving to the solution. For an LR circuit, you know a resistance calculated by V by upon I. It is become out to be 100 ohm. And for LR circuit, you know like resistance simply V equals to IR. So R equals to V by I. So for LR circuit, is the resistance is given by under root XL square plus R square under root. It's your net resistance, which will come out to be simply E by I. E is your given by 100 volt and R I is given by 0.5 ampere in this question. So from here you get the value of this and you know the value of R from another equation. Putting all the values and solving for it, you get the value of L that will come out to be root 3 by pi. Henry. Option A. Okay, there is a millihenry also, so don't be confused of it. Do the calculations properly. So correct option will be option number A is the correct option. Now moving ahead. Choose the incorrect statement. The magnetic flux is a scalar quantity. Okay, it is a correct. The magnetic flux is given by this. It's also correct. The unit of magnetic flux is this. The dimension formula of the magnetic flux. Tesla, you can calculate the dimension of magnetic flux. It's the B dot A. So means BA. Unit of magnetic flux is this. From here you get the dimension formula of magnetic flux equals to ml square t to the power minus 2 and a to the power minus 1. But it doesn't matches with this formula. So this is the only incorrect option among these. So the correct option will be option number D, because here it is asking about the incorrect. You need to find out the incorrect, and D is the only incorrect. So it's your answer. Moving ahead. In a coil of resistance 200 ohm, a current is introduced by changing the magnetic field through it. The induced current versus time graph as shown in the figure. The magnitude of change of flux through the coil. It is asking about the change of flux. Now you know change of flux can be calculated using the Faraday law. So moving to the solution, EMF induced is given by E equals to d phi by dt, and where phi is the magnetic flux. So EMF induced is also given by E equals to v IR. So equating these equations, and you get the value of EMF equals to d phi by dt, and putting the value of EMF here, you get E dt equal to d phi, and E is given by IR dt equals to d phi. So by using this, you get the area under this IT curve gives your change in flux. So just calculate the area under this. Area under the I dt will is equals to d phi. This is your main equation. So area under IT graph will give you the change in flux. So just calculate the area, which is your triangle. So calculating the area will give you 1000 Weber. So the correct option will be option number B. That is your 1000 Weber is the correct answer. Now moving ahead. A coil resistance is given, inductance is given, voltage is given. Energy it is stored. It is asking. You know energy is given by inductor case half Li square. So you know L simply. You just need to calculate I from here. You know resistors. You know L. You know voltage. I can be simply calculated by V by R. You know R. You know V. So from here you get I's value, which is 100 upon 10. That's simply equals to 10. Putting the value, you get the energy stored, that is equals to 250 joules. So the correct option will be option number A. Here remember that here it is written in 250 hours also. So take care of the options also. Don't do mistake. Now moving ahead. An inductor of inductance L, capacitor of capacitance L, C, and resistor R. Please voltage V. The values are in potentials are given. Amplitude of current is given. Impedance of the circuit is again a simple version. Impedance of the circuit is asking. What do you mean of impedance? Impedance with Z. Z means what? V RMS upon I RMS. So just need to calculate the V RMS upon I RMS. The V RMS can be calculated in the LCR circuit by using this formula. We get V RMS, and I RMS is simple given by Your I naught by root 2 is your RERMS value. Putting the value of I naught, because I naught means amplitude of the current is given 10 root 2. So putting the value, you get IRMS, you get VRMS, ZRMS, Z can be calculated by VRMS by IRMS. That is your 5 ohm. So correct option will be option number A. It's again a formula based question. Now moving ahead, calculate the capacitive reactance. Okay, it is asking about the capacitive reactance. Means XC it is asking of 10 60 watt, sorry, it is written in this way, 10 watt and 60 volt. When connected to switch AC, to 100 volt. Okay, it is connected to 100 volt. Now moving to the solution, we know resistor equals to V square by P. We want to calculate the resistor of the appliance. From here we get the value of resistors, and by using power and V, we get the value of current. Now impedance is in the RC circuit is given by under root of R square plus XC square, that is equals to V by. Putting the value, it is the same question that we solved previously when we need to calculate the inductance, where we calculate XL. In also that question, we calculate R by two methods. First Z and another V by I. Equate this, we get the value of XL over there. Similarly, the same thing is we are doing here. We get the same value. From here we calculate XC, that will come out to be 480 ohm. And so D is your correct option. Now moving ahead, the inductance between this is asking. It's again a simple question. You need to understand that we need to calculate the equivalent of it. Just use the potential method V, O. All are connected between V and O. So all are in parallel. Just use this condition. Parallel, it behaves as a resistor. 1 by R equivalent equals to 1 by R1 plus 1 by R2 plus 1 by R3. My main aim is to make you understand the concept. You can do the calculation by your own self. So your inductor will come out to be 1 Henry. Moving ahead, an inductor coil having these terms provides a magnetic flux of this, and current is 0.2 ampere. The coefficient is again a formula based question. You know, like simply N phi is equals to Li. You know many things. It is just asking about the coefficient. L you are asking. Turn is given, phi is given, I is given. Put the value, get the value of N. Just this calculation. Just do this calculation. Once you do it, L will come out to be 250 mega Henry. The option is the correct answer. Now moving ahead, consider resistive and their characteristics. Okay, purely resistive, current may source lag no, leads no, current also same phase. Means like P, O, LR circuit, simply it is asking LR circuit, RC circuit. In RC circuit, voltage simply your like lags. Here, LR circuit simply your current source lags. In this RC circuit, simply your current lead, and in LC circuit it may, because in LC circuit resonance occur now, so it may be possible that current may lead or lag. So correct option will be option number C. It's again a theoretical question, not a numerical. Okay. So you must need, in this chapter you must know the theory also, because many questions, as you can see, there are many questions built on theory. Which one of the following is true in LCR circuit? The power rating is element in the circuit average power rating. Yeah, exactly. The power consumed in AC circuit never negative. Yeah, because it completely goes into the resistive circuit. That's why its average power is never negative. The power factor is measure of how close the circuit is to expanding to maximum power. Exactly. Power factor basically tells about how much maximum power you can get from that particular thing. So all options are correct. D is your correct option. You can also read the explanation here. That you can get this PDF in the app and you can read the explanation from here. I explain on the basis of just my knowledge of theory. These are the characteristics of LCR circuit, which we have read in your classes during your regular days. A capacitor of capacitance is given. Resistance, okay, resistance of resistance 12 ohms should be there. Current series with voltage is given, okay. V naught is given, omega is given. Average power, it's again a simple question. You know power is equals to V RMS, I RMS cos phi. Cos phi is simply R by Z. You know V RMS, you know I RMS. Okay, no, you need to calculate I RMS first. You need to calculate I RMS. You cos phi you can easily calculate R by Z, as you can see in the solution. R by Z. So VRMS is simply your V naught by root 2. IRMS is simply your I naught by root 2. Putting the value, you get VRMS. You get what? Z. It is asking what IRMS is simply VRMS upon Z. Because you know now VRMS is equals to IRMS into Z. So from here you get IRMS, VRMS upon Z. VRMS is this, Z is this. So from here we get IRMS. We know VRMS, we know IRMS, we know R by Z. So putting all the values, you get the value of power, that is 2700 watts. That's your first option. Moving ahead, an isolated solenoid cross-sectional area is given. Turns per meter is given. A small n is given. Don't confuse with a capital N. At the center of solenoid, another coil. Okay, it's a concept of mutual inductor wrapped around it. If the current of coil changes from this in this second, the EMF develops. It's again a question of EMF, which will be given by simply minus EMF is, sorry, no, this is also true. EMF in the case of mutual inductance is given by minus M di by dt. Okay, so as looking into the solution, you know M is given by mu naught N1 N2 by A. Putting all the values, you get the value of M, which is the coefficient of mutual inductance. Now di by dt is given by change in current upon change in time. So you know change in time is given by this. Change in current is 2 minus 0, that is 2. So 2 by 3.14 millisecond. So 2 by 3.14 millisecond, you know the value of M. Getting the magnitude of it will come out to be 4 millivolt. So correct option will be option number C. Now moving to the next question. Again a theoretical question. In a above diagram, a strong bar magnet is moving towards solenoid B. Okay, it is moving towards B from solenoid A. The direction of induced current in one and that in two. Okay, it is asking the direction of current in both. Here we know we need to use Lenz's law. Lenz's law always opposes the cause. So as it is moving in this way, flux is increasing here. So current will be in such direction that it will decrease it. So current will be in the from C to simply your current will be from in this second coil. Current will be from your this way. So current will be your this way, so that it will like it can decrease it out. So simply here the flux is increasing. So if the flux is increasing, current will be in such a way that it will decrease the value of the this flux. So if the current will like this way, current will be simply your in this way, because the if the coil is starting from above, then it should be in this way. But here coil starts from below. So current should be, as you can see, this is the below. So in the below, as you can move, current will be in down direction. Okay, and in the above, it's in the like this way. So the current should be like this, because the wire is in this way. So if the current is in this way, means like from C to D, it will increase. So it should be in direction of D to C, because if the current is in this way, then it will increase there. But Lenz law says it can't. It opposes the cause. So current will be from D to C. So two options are there, and here current flux is decreasing. So it wants to increase the flux. So current will be in this direction from simply A to B. So that net flux will be in this direction. So option C is your correct answer. Now moving ahead, it's again a theoretical question. Which of the following statements is correct about induced electric fields? The fields are produced by variation of magnetic field. Exactly correct. Conservative. No. Induced electric fields are not conservative, because the curl of that field is not equal to zero. Okay. We cannot define potential. No. We can define the potential for it. Like this is the thing. It is asking about the correct statement. The lines of the induced fields are not closed. No, the lines of fields are closed actually. Induced electric fields, the lines are closed fields. And induced electric fields are not conservative in nature. But here, the potentials, the original potentials are not like able to we can define. As you can, we cannot define a potential corresponding to this field. Like I have a like there are two types of potential. Actually, this is not studied make studied in your like class 12 actually, but in graduation you will come to know about that. Like we can define uh, induce potential for these fields also, but these are not that potential which you see that is B. Simply that is your B. That not that is these potentials are called generally vector potentials. We generally used to define for it. Okay, so this is the thing that you need to understand it out. So correct option will be option number A. The field are produced by variation of magnetic field with respect to wait. Magnetic field with respect to space and time here should be a variation of when the magnetic field changes. Actually, these are the higher level questions. It comes from the Maxwell's equation, okay, which we have to read in class under graduation. We need to read it out. From Maxwell equation, we get that del cross E is equals to minus del B by del T. So when magnetic field changes with time, now then it will. So option A is also incorrect. And as this is non-conservative field, so the as the curl of this is not zero, so it is not conservative. So if it is not conservative field, we can't define like normal potential. So I think according to this, option third is the only correct option here, because yeah, in your class it is talking about a normal potential, okay, a potential related to this field. So we cannot define the potential for induced electric fields. Okay, this is the thing. This is the outcome of this Maxwell's relation. So actually, I think here wrongly it is mentioned that uh, it is not like that. It's a variation of. It should be, according to me, it should be C, because the this fields generate due to variation of magnetic field in which time, actually, which time, not space. That's why there is a confusion. Okay, in this. So I will go with the option number C. Now moving ahead. In an LC oscillation, maximum charge on the capacitor is Q naught. If at any instant electric energy is three-fourths of magnetic energy, okay, then the charge on the capacitor at this instant. You know, like electric in an instant, the electric energy is three-fourths of the magnetic energy. In a capacitor energy, you know, if the capacitor Q naught square by 2C equals to magnetic energy, that is half Li square, and the electrical energy Q square by 2C. From here, we can get the value of what? Q value. That in terms of QC. Simply, as you can see in this one, doing the calculation, we get the value of Q. That will come out to be root under 3 by 7 Q naught. That is your the whole root in this way. B is your correct answer. Now moving ahead to the next question. The value of capacitance in LCR circuit, it is asking actually. L is given, omega is given. When the current is maximum, okay, current is maximum in resonance, 1 by LC. So from here, you know omega, you know L, you just need to calculate C. It's again a formula of this question. So C will come out to be, after looking at the calculation, 1 millifarad. That is B is the correct answer. Now moving ahead, again theoretical questions. Magnetic field can produce EMF. No, magnetic or can't produce change in magnetic field can produce. Faraday law established induced experiment. Exactly. Option B is your correct answer. Assumption is false, but reason is true. Moving ahead, the correct statement among which is are or false. Is or are false. The EMF can be produced by time varying magnetic field in the coil. Yeah, it can be produced. The EMF can be induced by moving a circular polymer. Yeah, it can be produced. In electromagnetic induction length law, boys, no, it's supposed the energy of conservation law. So option D is the correct answer. It's again a theoretical question. Now, in a series LCR circuit, the value of C, L, and R is given. When the current is maximum, means resonance, the ratio of energy stored in the capacitor to the capacitor Q square by 2C, and inductor half Li square. Simple. You just need to understand, or if C or B is given, half CB square is also the way. So it's again a simple question. You just need to understand it out. You just need to calculate the ratio. Convert, you know C, the value of C here. You like you don't know the value of I here. I know this, and you also don't know the value of V. So just convert V into I. V equals to IR. Put the value V square equals to I square R square. I square will cut out. You know the value of R. Putting all the values, you get the ratio 1 by 5. D is your correct answer. It's again a formula based question. You just need to calculate the ratio out of it. Now moving ahead. In a series LCR circuit as shown in figure, the voltmeter and ammeter readings are this. Okay, it is asking about the voltmeter. It is series LCR circuit. R is given, L is given, T is not given actually here. But wait, it's asking about the voltmeter and ammeter. Voltmeter is here, ammeter is here. Okay. Now you know voltage is simply your, as you can see in the solution LCR circuit, the voltage is given by this way. As according to the figure, as you can see, L or C, actually there is a mistake in the figure. Okay, C should also be given, otherwise it can't be solved. As you can see in the solution, L and C are equal, so means like it is nearly equal to 1000. Therefore, net potential will be your VR, that is your along the resistor, and it all behaves as a resistive circuit. Now you can calculate current, that is equals to V by R. So V is equals to your 100 and R is equals to 50. It's 2 ohm. So reading will be your 2 ampere, okay, and voltage will be 100 volts. So the correct option will be option number A. Because the L and C, L and C both are equal. Here it is not mentioned in the figure. The figure is wrongly pasted here. So that's why it's behave as a resistive circuit only, and then you can easily solve it as a resistive circuit. Again, like a question from transformation. A power setup transformation with a ratio itna turns turn ratio has this frequency, this volt across a primary. The load in the secondary is this. The current in the secondary. It's again a formula, simple formula based question. You need to understand that this formula NP by NS equals to VP by VS equals to IS by IP. Just use this formula and get the value. As you can see, these are the NP, the number of turns in primary, number of turns in secondary, potential across the primary, potential across the secondary. Here you know turns ratio are given, potential in one is given, so you can calculate the potential in another, that is your Vs in the secondary. Now what is asking? Current it is asking in the second, so you know current in the second it is asking. So load resistance in the second is the 10 to the power 4. Actually here it is wrongly mentioned. Load resistance. There is a mistake in the question. Read it properly. Okay. Load resistance is given as a 10 to the power 4 ohm. So you know the load resistance in the secondary. Sorry, load voltage in the secondary. We know the load resistance in the secondary. So we can calculate the current in the secondary, that is V upon R. So here it will be 96 milliampere. B is your correct option. Here load resistance is missing from the question. That's why I'm explaining you the missing things. So there are sometimes typing issues are there. Okay, so we need to clear it out. Now the next question. The magnetic flux is changed through a coil of resistance this. As a result, induced current is developed which varies with the time as shown in the figure. This current is varying with this time. Okay. Now the magnitude of net flux. Oh, you already know change in flux is given by I dt. Area under the IT graph. Simply it's a triangle half into base into height. Putting the values, get the value 0.6 into half into base into height. 0.6. Okay. So 0.6 is your this, and magnetic flux change through the coil of 5 ohm. Okay. The magnitude of net change flux through the coil. This is the change in flux. This is the thing. It is asking about the net flux change. Wait for a second. Magnetic flux is changed through a coil of resistance 5 ohm. Okay. There is a coil through which magnetic flux is changed, whose time and graph is given. Okay. So we know change in flux. Okay. Let me do a calculation a little bit. EMF is equals to what? Minus d phi by dt. EMF is equals to V equals to IR. Oh, I got it. IR equals to in magnitude d phi by dt. So your I dt should be equals to d phi by R. So your d phi is given by R into d I dt. Okay, okay. R should be multiplied. Yeah, that's why 5 is multiplied here. It's 3 Weber. B is your correct answer. And that's why I'm telling you, never remember the concept. Try to develop, try to derive it. So it can be, if sometimes you are confused. I am also confused sometimes, even many times. That's why I use derivations over there. Now moving ahead, two conducting rods of length L, okay, and length 4L, moving in opposite direction, okay, four velocities are given. Conducting surface S, okay. There is a uniform magnetic field, it is given here. The potential difference between the highest point P and Q, okay. It is asking the potential developed on both the ends, then you need to calculate the difference. So you know, EMF is developed is equal to BLV. In this case, B is given B, L is given 4L, B is given V. Here 4BL. It is simply both same. So it will be 0. Wait. B L is 4L and then it is V for this end. And okay, no. Because the magnitude is same. Actually, the point is that total potential difference across this is R. So you need to understand that the total potential difference across these two rods are R. So the total potential difference is simply the sum of both the potentials. Because you can understand this in this way. Okay, if something is moving in the magnetic field, how can there be no potential difference? Okay, how can there will be no potential difference? So potential difference is added here because it is asking for the total potential difference. Okay, between the highest point. So people easily get confused by zero. So the correct option will be option number B. That is 4BBL plus 4BBL. It is not asking about the potential difference among the same road at two different endpoints. That's a different thing. It is asking about the two different rods. So the total potential difference will be added together because for one road it's 4 BBL, so potential difference, and for another it's 4 BBL. Now for these two it will be 8 BBL, but for one particular rod it's 4 BBL. So need to remember this. Now moving ahead, it's again a very famous PYQ question. Two conducting circular loops of radii R1 and R2 are placed in the same plane where their centers are coinciding. R1 greater than R2 mutual induction. It is asking for the mutual induction. You know magnetic field coil mu naught I by 2R. You know phi is equals to BA. So from here, as you can see in the solution, one is R2 and outside is R1 and inside is R2. Outside there is a current. So magnetic flux is BA. So B is the magnetic field and flux through inside coil. So you know M is given by phi by I. Putting the value of phi and putting the value of I here, you get the value of M that is proportional to R2 square by R1. So the correct option will be option number A. It's a PYQ questions. Okay, so you have also solved it previously. It's based on the mutual induction concept. Now moving ahead, a coil of inductive reactance is given. Okay, has a resistance. Okay, a coil of inductive resistance 33 ohm has a resistance of an 8 ohm. Here it is missing 8 ohm. It is placed in series with a capacitive reactance. Again, the unit is missing. The combination of the connected source of ethanol, the power factor, is again the same question. You know power factor VRMS, IRMS, cos phi. Cos phi is simply R by Z. VRMS is your simple, you can calculate it V naught by root 2. IRMS is equals to simply your VRMS equals to IRMS into Z. IRMS equals to VRMS by Z. Z can be calculated by under root of R square plus XL minus XC whole square. So just do the calculation. As you can see in the solution, we calculate the Z. From where we get the Z, we know the R. This is your cos factor. Cos. Okay, it is asking about the power factor. Okay, it is not asking about the power. It is just asking about the power factor. So just calculate cos phi, which is equals to R by Z. You know R, you just need to calculate Z. It's a basic question. C is your correct option. Now moving ahead, the variation of current with time is shown, the average value of the current in the half cycle. Okay, it is asking from here to here. The average value it is asking from here to here. Now you need to understand the average value. As you can see, this is t by 2, so this is t by 4. Okay, so for the whole it can't be 0 because it's positive, but for whole it's 0, but for the half cycle it's simply I naught by 2. Simple. It's a theoretical question. But if it is a full cycle, then it is 0. But half cycle, it's I by I naught by 2. Moving ahead, a 800 turn coil effective area is given kept open to the magnetic field is given when a plane is rotated by this. It's again a simple question. EMF is equals to delta phi by delta t. Delta phi you need to calculate and B A simple. Magnetic field is given a cos theta simple. Rotated by 90 degree. So pi initial, pi final minus pi initial by delta t. Delta t is given. For pi final, theta is equals to 90 degree. For initial, theta equals to 0 degree. You use this formula of EMF pi. Just put the value and get the answer. It's very simple question, and once you solve it out, it will come out to be 0.02 volt. So please like check the calculation. I just explained you the concept and reasoning behind it. Rest of the things you can do. If you can't do right now, how can you be able to do it in exam? Don't be just like behave like every teacher should tell you everything. Even do plus minus. It is your thing, yeah. You should be careful about it. Now moving ahead. In series LCR, VL is given, VC is given, and applied voltage is given. Part. It's again a simple question. You just need to use calculate the power factor. Power factor is simply your cos phi or tan phi is written in the form of this cos phi, and you just need to calculate the phi angle. And phi angle by using potential, you know, only calculated by V total by VR. V total is your simple. Then it is only LCR circuit now. So for your V, that applied voltage is given this. Okay, if applied voltage is given this, you can just put, wait for 1 second. Here what is given? VL is given, okay. VC is given. Here VR is not given, okay. Here total V is given. Total V is given by this, and you don't know VR. You need to calculate VR using this equation. As you can see in the solution, total V is given. We calculated VR. Then by using impedance triangle, we calculate phi. Phi is perpendicular by base. So perpendicular is this, base is this. Putting the value, you get phi. Once you get the phi, you get the value of cos phi. That is 0.6. Option number first is the correct answer. The reading, it's again asking the reading. As you can see, again L and X, L and C are same. Again, it's a resistive circuit. If it is resistive circuit, again the potential is your simple. XL and XC are same. Again, its potential, your current will be simple. Your potential by Z. Potential is 110, Z is 55. It's again a simple question. 2 ampere is your current. In an adjoining figure in a sleeve LCR connected to a variable frequency 200 volt, L is C is this, R is this, then source frequency at the circuit. It is asking about the source frequency. LCR connected to a variable frequency LCR is given. Okay. The source frequency that drives the circuit at again a very simple omega is equals to under root of 1 by root LC. Omega is equals to 2 pi F equals to 1 by root LC. F is equals to 1 by 2 pi root LC. Just put the value, get the value of omega. It is asking about the, if it is asking omega, you get this. If it is asking about the frequency, just omega is equal to 2 pi, the frequency is equal to this by 2 pi. It's asking about omega, so 50 hertz is your correct answer. The magnetic potential energy stored in a certain inductor is 25 millijoule. When the current in the inductor is this, the inductor of the inductance. It's opposite the inductance of the inductor. Inductance of inductor. So it is just asking about the inductance of inductor. Energy is given, you know, half Li square. I is given, U is given, L you just need to calculate. That will come out to be 3.89 Henry. 13.89. This is your correct option. A circular area of this kept inside a magnetic field perpendicular to a plane. Okay. The magnetic field changes. Okay. In 10 seconds. Okay. The resistance in this heat involved. You just need to understand how to calculate heat here. It's again like you just need to calculate EMF. EMF is given by change in flux by change in time. Flux is BA. Area is given. Final B. Area final minus B initial A final. Simple. Change in magnetic field is given. Area is same. So it will be a simple 0.02 into 2 upon 10 millisecond. 10 millisecond. It will be like this. This is your EMF. Once you get the EMF, you need current. Current is equals to what? Phi equals to V by R. Putting the value, get the current. Then simply it is asking about the heat involved. Heat involved is I square RT. Y square R. E is I think T is missing. Heat involved. Okay, what is it is asking about the sorry rate of heat, because heat is given by I square RT now. So rate of heat is I H by T equals to I square R. So rate of heat is given by H, that is also called power. You can also ask power, that is come out to 2 joule per second. Now moving ahead, it is asking about the change in the potential difference here. Length is given, omega is given, so velocity is given. Just need to calculate the potential for both V and VB. You know, potential is given by B omega square L, B L omega square, B omega L square by 2. So for one L is this, omega is this, B is this. For another L is this, omega is this, B is this. Put the value BA and BB, get the difference and get the value of it. Again, end question. You can see this is the formula. Apply for VA means A rod, then apply for B rod, then take the difference out of it. Because it is asking the difference, not the total potential. Moving ahead, simple. After moving ahead, you can see here the 0.2 milli Henry is given here. Okay, so be remember. We will continue this because of the electricity, so we will continue these two questions in the next video, but it will be short definitely. So I will try to continue in the next short. Thank you very much.